Hello everyone, my name is Ege. Today I'm going to present you my lab project about induced electromotive force by Faraday's law. In this experiment, Faraday's electromagnetic induction law will be tested by measuring the induced MF with different numbers of loops and coil areas. The measured data will be compared to the expected data from the law. I will take the magnetic field as a constant, the change in magnetic field as constant. We'll change the radiuses of the coils and the number of turns on coils, and I will try to measure the different MF on my experiment. Setup of my experiment is relatively simple. Here you can see my equipment: a multimeter, foil coils with 2 centimeter radiuses, and 10, 20, 30, and 100 numbers of loops. And I also need 4 coils with 2, 4, 6, 7 centimeter radiuses and 10 number of loops. We also need crocodile cables to connect the coils into multiplexers, a magnet and a stronger magnet for the second part. Also a ruler here. On the second part of my experiment, I measured the MF related to the number of turns. Here you can see me conducting the experiment with 4 different coils. I measured my MFs and I put them in my table here, as you can see. I did for the 4 different coils with 10, 20, 30, and 100 turns. On the second part of my experiment, I measured the MF related to the different radiuses of the coils. I measured my coils with 2, 4, 6, and 8 centimeter radiuses. I used a different kind of coil, so I had to measure the 2 centimeter 10 number of turns coil 2 times, which is why the voltage in this one is different. Here you can see me conducting the experiment. After measuring the wave data, I processed my data using the Faraday's law of induction. I got measured values and calculated values for my experiment. I graph, you can see voltage related to the number of turns, and the second one, you can see voltage related to the radius. First one increases linearly on both measured and calculated side, and on the second one, it both increases exponentially both in measured and calculated side. For the last part of the experiment, I put measured and calculated values into the following table and calculated error percentage for each of the coils. On this table, we can see for coils with different number of turns, there is an error increase in both measured and calculated data. And our error percentages shows that our experiment has succeeded on the part 1. For the different radiuses, we also see a quadratic increase in MF, which was expected because magnetic flux use power of 2 of radius to calculate area. And this also shows that our experiment succeed on the part 2. Results of both parts proves that dependencies on the Faraday's law was correct and our experiment succeeded overall. The weakness of this experiment is that the change in magnetic field couldn't be constant because the instant we calculated the magnetic field, the difference between magnet and coil is different on each radius with different coils with different radiuses. So in order to prevent that, I use a stronger magnet, but if a uniform magnetic field could have been used, it would have much. Also, human errors, equipment errors, and environmental errors are an important part of the weaknesses. Strength of this experiment is that I used same material for each coil for their own parts, and also I released the magnet from the same height for each of the experiments. For better results. The experiment could have been improved with uniform magnetic field for part 2 and using better equipments overall.